So hi friends, this is your Prashant sir. Welcomes you to the World of Physics from KH Patel PU College, Hubballi. So today in my third lecture, I am going to discuss the general properties of nucleus. So we know that nucleus has certain properties. So we will try to discuss one by one. So the first one, size of the nucleus. So the size of the nucleus. The size of the nucleus or the volume of the nucleus it clearly depends upon the atomic mass number. So first of all, nucleus has a definite size. So we have to know that, we have to understand that the nucleus has a definite shape and size. And this size of the nucleus, or I can say that for size of the nucleus, in other words, I say that volume of the nucleus is clearly depend upon the atomic mass number. So how? To know the size of the nucleus or volume of the nucleus, the radius of the nucleus is necessary. That means nuclear radius is necessary. So that nuclear radius is clearly depend upon the atomic mass number. So this radius of the nucleus, capital R, is always directly proportional to a to the power 1 by 3, where a is atomic mass number. That means this radius of a nucleus and the atomic mass number are directly proportional with each other. That means if atomic number increases, the radius of the nucleus is also increases. And alternatively, if the radius of the nucleus increases, the size of the nucleus also increases, the volume of the nucleus is also increases. That means it is clear that the size of the nucleus or volume of the nucleus is clearly depend upon the atomic mass number. So from this equation, if we remove proportional sign, then we will get the equation for radius of a nucleus or nuclear radius, that is given by R is equal to R naught into a to the power 1 by 3, where R naught is a constant of a proportionality, or it is also known as Fermi constant, and the value of a Fermi constant is given here, that is 1.2 into 10 to the power minus 15 meter. 1.2 into 10 to the power minus 15 meter. It is the value of constant known as constant, or it is the value of a Fermi constant R naught. R naught. I think it is clear. So from this explanation, it is clear that the size of the nucleus or the volume of the nucleus is clearly depend upon atomic mass number. As atomic mass number increases, the size or volume of the nucleus is also increases. And the nuclear radius is given by the formula R is equal to R naught into a to the power 1 by 3, and R naught is known as constant or Fermi constant, and the value of R naught is 1.2 into 10 to the power minus 15 meter. So I think this much is clear. So now next, so some notes are given here. The nuclear radius, in first note they have expressed that to measure the nuclear radius or the diameter of the nucleus or the size of the nucleus, we will have to use the unit of length, that is the smallest unit of length, that is Fermi. And this 1 Fermi is nothing but 10 to the power minus 15 meter. So always nuclear radius will be of the order of Fermi. We have to remember this, that always the nuclear radius will be of the order of Fermi. It is very small. The nuclear radius is very small. That is, it is in the order of Fermi. That means 10 to the power minus 15 meter. 1 Fermi is equal to 10 to the power minus 15 meter. So, and this Fermi is the smallest unit of length. In second note, they have expressed that Fermi is the smallest unit of length, and 1 Fermi is equal to 1 into 10 to the power minus 15 meter. 10 to the power minus 15 meter is equal to 1 Fermi. And this nuclear radius or the diameter of the nucleus is of the order of Fermi. But atomic radius or the diameter of the atom is always of the order of angstrom. So that is given in third note, that atomic radius is of the order of angstrom, and 1 angstrom is equal to 10 to the power minus 10 meter. So to measure the nuclear radius, we will use the unit of length as Fermi, and to measure the atomic radius, we will use the unit of length as angstrom, because the nuclear radius is of the order of Fermi and atomic radius is of the order of angstrom. And the fourth node, look at here, fourth and fifth nodes are very important. The smallest nucleus in the nature is hydrogen. The smallest nucleus in the nature is hydrogen and has a radius of 1.2 Fermi. The smallest nucleus in the nature available is hydrogen and it has a radius of 1.2 Fermi. And the biggest nucleus in the universe, the biggest nucleus in the nature is uranium 92 to 235. Sorry, it is not only the 9 is printed here, it is 92. Uranium 92 230 has the radius of 8 Fermi. So the largest or the biggest nucleus in nature is uranium 92 238 has the radius of 8 Fermi, and the smallest nucleus is hydrogen, has a radius of 1.2 Fermi, and the largest or biggest nucleus in the nature is uranium 92 238 has the radius of 8 Fermi. So this is about size of the nucleus. So the next property of the nucleus is charge, that is a nuclear charge. So we know that the nucleus contains protons and neutrons. So neutrons are neutral in nature, protons are positively charged. So therefore the charge of the nucleus is only due to the protons. And protons have positive charge means the nucleus is also has positive charge. So the net positive charge present in the nucleus is called nuclear charge. That means nucleus has a positive charge because of the presence of protons, and it depends upon the atomic number, because the atomic number is nothing but the number of protons present inside the nucleus, right? So atomic number is nothing but the number of protons or the number of protons, atomic number or number of protons. That means the charge of the nucleus is clearly depend upon the number of protons. So the charge of the protons is given by Z into E. It is given here Z into E, where Z is atomic number and E is charge, where E is equal to 1.6 into 10 to the power minus 19 coulomb. So where Z is the number of proton, atomic number or the number of protons, and E is a charge of individual proton. E is the charge of individual proton. So total charge of a nucleus is given by the number of protons into charge of each proton, and it is given here. Nuclear charge is very important factor in atomic physics. It determines the energy levels of an atom. So to determine the energy levels of an atom, this nuclear charge is very important. So to know the nuclear charge, we will use a certain procedure. So in that one is alpha scattering method or X-ray spectrum. So these are higher concept. I am not going to discuss all these things. In second property, that is nuclear charge, the charge of the nucleus is positive, and it is because of the presence of protons. The charge of the nucleus, the net charge of the nucleus is positive, and it is because of the presence of protons. And the charge of and this nuclear charge is clearly depend on the number of protons present inside the nucleus, and that is nothing but the atomic number. This charge of the nucleus is clearly depend on atomic number. So this is second property of the nucleus. So now coming to the point of third property, that is nuclear mass. So we know that nucleus contains protons and neutrons. So nucleus contains protons and neutrons. So this nuclear mass is the sum of masses of protons and masses of neutrons. The nuclear mass is the sum of masses of protons and masses of neutrons present inside the nucleus. Right, so nucleus contains protons and neutrons, and this nuclear mass is the sum of masses of protons and masses of neutrons, and it is given by the formula here. It is actually here, that is capital M, where capital M is the nuclear mass, and that must be equal to ZMP, where Z is atomic number, and atomic number is nothing but number of protons, into MP. MP is here it is MP. So MP is nothing but the mass of each proton. So Z is the number of total protons, and MP is mass of each proton. It will gives you the total mass of proton, plus A minus Z. Here it is A minus Z. So A minus Z is nothing but the number of neutrons, into Mn. Mn is nothing but the mass of each neutron. So the number of neutrons into the mass of each neutron gives you the total mass of neutrons present inside the nucleus. So sum of total masses of protons and the masses of neutrons gives you the total mass, or that is nothing but the nuclear mass, the mass of the nucleus. So I think this is clear. So everything is given below here, where capital M is mass, nuclear mass, MP is, so here it is capital M, the nuclear mass, MP, the rest mass of the proton, Mn, the rest mass of the neutron. The value of MP is given here, that is mass of a proton 1.672 into 10 to the power minus 27 kg, and the mass of neutron is given here, that is Mn, that is equal to 1.675 into 10 to the power minus 27 kg. So I think this is clear about the nuclear mass. So simply, nucleus contains protons and neutrons. The sum of masses of protons and the masses of neutrons present inside the nucleus will give you the nuclear mass. So, and this is given by the formula M is equal to ZMP plus A minus Z into Mn, where Z is the atomic number or the number of protons, A minus Z is the number of neutrons. MP is mass of each proton, the rest mass of each proton, and Mn is the rest mass of each neutron. And this is about nuclear mass. So the next property is nuclear density. This nuclear density is defined as the ratio of nuclear mass to its nuclear value, and it is given here. It is given here. That is, nuclear density is equal to nuclear mass divided by nuclear value, and it is constant quantity. It is independent of nuclear mass number. It is independent of mass number. It doesn't depend on atomic number, or it doesn't depend on mass number. It is independent quantity. As the nuclear mass increases, the volume also increases, but the ratio remains the same, and therefore this nuclear density is constant, and that is given by rho is equal to 1.815 into 10 to the power 17 kg per meter cube. So nuclear density is the ratio of nuclear mass to its nuclear volume, and it is always constant, and it is independent of mass number, it is independent of atomic number, it is independent quantity and always constant quantity, and that is given by nuclear density is equal to nuclear mass divided by nuclear volume. It is constant quantity. It is given by 1.815 into 10 to the power 17 kg per meter cube. 10 to the power 17 kg per meter cube. So next one is nuclear energy. So the energy associated with the nucleus is known as nuclear energy. In later classes you are going to study everything about nuclear energy, so I'm not going to discuss large things here, but I just want to give you a hint that this is the energy associated with the nucleus, and the energy is very high. It will be expressed in terms of a mega electron volt. It will be expressed in terms of mega electron volt. So the last property is nuclear spin. So we know that the nucleus in the nucleus will be present at the center, the electrons revolving around the nucleus. There will be the relative motion between the nucleus and electron. So it is listen carefully. The nucleus is at the center, electron will revolve around the nucleus, and there will be relative motion between the nucleus and electron. So as we study the nuclear centric model, then the nucleus is at the center. If we study the electron centric model, if there is a relative motion between the nucleus and electron, then there is a possibility of electrocentric model. That means the electron is at the center and the nucleus is revolving around it. That means both are relatively moving with each other. That's why the nucleus revolving around it means it has an orbital motion. At the same time, the nucleus revolve around its own axis, just as Earth revolving around the sun, that is orbital motion, and the Earth revolving around its own axis, that is nothing but the spin motion. In the same way, the nucleus also has an orbital motion. So because of that orbital motion, there will be orbital angular momentum, and the nucleus also has a spin motion. That means it is revolving around its own axis, that is spin motion. Therefore, because of that reason, it has spin angular momentum. So the vector sum of spin angular momentum and orbital angular momentum of the nucleus is called nuclear spin. The vector sum of spin angular momentum and orbital angular momentum of the nucleon is called nuclear spin, and it is given here I is equal to L plus S, where I is the nuclear spin is equal to L plus S, where L is orbital angular momentum plus S is spin angular momentum. So I think these are the some very important properties of a nucleus. Please go through it. Please read once again. Please write in your own notes and try to read everything. Try to understand everything. Try to understand the properties of nucleus very clearly. I hope you guys understand this. Thank you very much.